Alright, in this video we're going to be talking about electron pair geometry. That's the geometry around the central atom, and it's the geometry that the electrons take on. Okay? So the electron pair geometry shape is basically focused in on this thing called a steric number. So steric number basically is the number of groups hanging off the central atom. We don't care if they're bonding or non-bonding, it's just the number of groups there. So here we've got an example of a steric number. When the steric number is 2, it tells us that the geometry is going to be linear. Now this is the electron pair geometry. Okay? And linear would basically look like something like this. See, they're all in a line. Here we've got the central atom, and we've got one group on this side and one group on this side. Okay? That's 2 groups off the central atom. So here are some examples. Here we actually have a molecule where we have 2 central atoms. You have, for those types of molecules, you have to determine the geometry of both central atoms. So this carbon has 2 groups hanging off of it. It has the H group and it has the CH group hanging off of it. So right there, that center is going to be linear. Same thing over here. It's got 2 groups hanging off of it, 1 and 2. And so this side of the molecule will be linear. So the whole thing ends up being linear. Now let's look at this guy. Now he's linear because he also has 2 groups. We look at the carbon. The lone pair is one group, and the oxygen is the other group. Okay, remember, we're not looking at the number of bonds or anything like that. It's just the number of groups off that central atom. Okay. Now let's look at trigonal planar. This is basically the trigonal planar shape. If you have a steric number of 3, it's trigonal planar. It's planar because all 3 of these red atoms are in the same plane. When you hold it sideways, you can see that. And when you look at it like this, you can see that each one forms a little triangle on the side here. And the overall shape is a triangle. Okay. So the trigonal planars examples would be something like this. Here we've got a central atom of carbon. We've got 1, 2, 3 groups hanging off of it. And so the steric number for this is 3. And therefore it's trigonal planar. Now we can also have a situation like this where you have 2 atoms that are hanging off of it and a lone pair. That still has a steric number of 3. And so the geometry is still trigonal planar. Okay, let's look at 4. When we get to the steric number 4, now the red balls are what's hanging off the central atom. The central atom's blue. And we get this thing called a tetrahedral. Okay. Basically, there's a triangle formed on the outside of each of these sides with the outer atoms. And the central atom is stuck in the center. Okay. So that's trigonal planar. And let's look at some examples. Methane would be tetrahedral because it has 1, 2, 3, 4 groups hanging off of it. Ammonia is tetrahedral with respect to its electron shape. Okay, remember we're only doing electron shape right now. It's got the lone pair and it's got 3 hydrogens hanging off of it. That's a total of 4 things hanging off of it. So the electron pair geometry is tetrahedral. Even water. Water has 2 lone pairs and 2 H's. That's a total of 4 things hanging off of that oxygen. So water is tetrahedral, and I'll take on a shape similar to this. Now remember, these are the shapes of where the electrons are. Okay? They're not the actual shape of the molecule we see. So we're going to have a video later talking about the shapes that we actually see.